Well, today is an exciting day because we are officially starting the formal study of proof. And we're going to start by doing direct proofs. We're going to learn about 3 different kinds of proofs this year, and we're going to learn how to do 2 of them. And the first of them is direct proofs. And we're going to start by using algebra because we are all algebra experts now. And we need to do algebra before we get into the new stuff that we've been learning this year in geometry. So we're going to go back and dust off the algebra notes, and we're going to do direct proof using algebra, the stuff from last year. And please pardon my voice, I'm getting over a cold, so I may be pausing to grab a sip of tea in between examples, and so please just work with me on this. So, there are 4 parts of a proof: the given, what you're trying to prove, and then the statements that you make to prove that, and the reasons that you can make the statements. So, this is the law. You can think of this as the law. It's true, it's always true, you don't have to question it, okay? Prove is what you are trying to do. You try to do this. Okay? You try to do this. The statements are what allows you to prove that, and the reasons are the reasons that you can make the statements. So you kind of work your way back up the ladder right there. The reasons allow you to make the statements, and the statements allow you to prove whatever you're trying to prove. Okay? Most importantly, each statement or step, you can think of them as the same kind of a thing. Statements are steps in proofs, and you'll see that in a second. Each statement must have a reason. If you cannot find a reason for it, then chances are it's not a legal step to make. Okay, so you have to provide a reason for every step. For now. Because for now, we'll be doing what are called 2-column proofs, and they are proofs that consist of, you got it, 2 columns. But these are really just used to teach you how to do a proof. Mathematicians don't use them, okay? Please know this up front. I'm going to be teaching you something the first semester of this class that mathematicians don't actually use. They use something, or we use something, rather, called a paragraph proof. And after December, we will be transitioning to the paragraph proof also. So by the end of the year, you will know how to write a paragraph proof. But you can't learn how to write a paragraph proof until you know how to write a 2-column proof. So this is really just a teaching tool to teach you how to write a paragraph proof. These are a little bit more sophisticated, and this is what mathematicians use, and so we're going to transition into this after December. Okay? So, of course, like I said, we're using algebra today, and all of this that we're doing with algebra. So, I need you to turn back your clock in your brain, and we're going to go back to algebra last year. So, given that 9x minus 7 equals negative 7, prove that x equals 0. Okay? Well, wait a minute. Do we already know this is the case? Yeah. You're trying to show that this is the actual answer. So let me just explain to you what I'm saying really quickly here. Because you're not used to being shown an equation and given the answer. I'm giving you the answer right here. I'm saying yes, x is 0. So, by the way, you can always assume what you're trying to prove is true. Let me just write that out here. You can always assume what you are trying to prove is in fact true. It's not going to be a waste of your time. The stuff that I give you to prove will in fact already be true, but whether it's true or not is not your task. Your task is to create the proof. So if we were looking at this example right here, 9x minus 7 equals negative 7, we would say, oh, well, if I got to solve for the x, then I have to add a 7 and add a 7, and I get 9x, and those go away, and I have negative 7 plus 7 is 0, and then I'm going to divide by 9 and divide by 9, those go away, and so, in fact, x equals 0. But I already knew that because I'm told that. This is, in fact, exactly what's going to happen in this proof. We're going to figure out that x is 0, but we're going to show that that's actually the case. So, in this case, my given is 9x minus 7 equals negative 7. It's the same equation I had, and I'm asked to prove that x is 0. So I'm starting out with all this, okay? I have two columns, statements and reasons, and for every statement I have to give a reason over here. So if you look, let's put this side by side right here. This is how I solved this. The first thing I did was I added 7. I added 7 and I got 9x equals 0. Well, here's this step right here. How did I go from this, and what is this? This is what I'm given, right? It's what I'm starting with. Notice that that is exactly what I am starting with. So notice that I've started here with the given. You see that? It's the given. So why is this a valid statement? Well, it's a given. And in fact, your first reason, your first statement will always be what you're given, and the reason will be that it's given to you. Okay? And now, what did we do to that? Look over here. We added 7 to both sides, right? And when we added 7 to both sides, we ended up with 9x equals 0. That was our next step right there, which is exactly this step right here, 9x equals 0. So how did we go from step 1, and you can think of this as step 1, step 2, and step 3. How did we go from step 1 to step 2? We added 7. We added 7 to both sides. And what tells us that if we add 7 to both sides, it'll balance out like we expected to? It's the addition property. Okay, the addition property tells me that I can add 7 here and add 7 here, and each side will balance out, and here I'll get a 0, and here I'll get a 9x. That's what the addition property tells me. We use it all the time in algebra, but this is what it's actually called. And if you remember back to last year, we actually learned this. And then, what did we do? We divided by 9. We divided by 9 and got x equals 0. And that's exactly this step right here. But what told me that I was able to divide by 9 and divide by 9 and have this cancel out, and 0 divided by 9 is 0? How did I go from this step to this step? Just like how did I go from there to there? Well, it was by the division property, right? The division property. Because I divided by 9. And lo and behold, my last step right here is x equals 0. But if you look, that is my prove statement. Notice that this right here is my prove. It's my prove statement right there. And when you end up with your last statement being identical, and I mean identical, to this, then you are done. And as soon as you filled in your reasons for this, you can come out here and draw a little box that you shade in like that, and that is the mathematical symbol that a proof is done. A little shaded in box over here. And just to clarify exactly what that means, the shaded in box, and different parts of mathematics do this differently, but the shaded in box at the end of a proof, excuse me, you can also write the letters QED, which is Latin for quod erat demonstrandum, which means that which was to be demonstrated. that which was to be demonstrated. And so when you write that out, you're effectively saying that yes, the last statement I have made is that which was to be demonstrated. That which I was asked to prove, I have proved it. So what I'm saying with this little box here at the end is I'm saying that this statement right here is exactly that which I was asked to prove. Okay? So let's go on to another example here. And really with proofs, the secret is just to practice. Okay? So let's start out here. Okay? If v plus 9 if v plus 9 divided by 3 is 8, show that v equals 15. So this is our given. And we're asked to show that v equals 15. Okay? We've already given the answer here. We just have to show that it's the answer. So there's my given and my prove, and of course I'm going to have statements. And I'm going to have reasons. Now, my first statement is exactly what I'm given. Okay? You have to start there. Because that is what you're being told to start with. So that is a given. Okay? Now, what would our next logical step be? Well, our next logical step would be to multiply both sides by 3, right? And get rid of that denominator right there. So if I multiply both sides by 3, the 3 over here would cancel, and it would leave me with v plus 9. And over here, the 3 times 8 would leave me with a 24. So this was my next step, but what's my reason for that? The multiplication property. Multiplication property. And then of course I'm going to subtract 9 from both sides, and when I subtract it from the left I'm left with v, and then when I subtract it from the right I have 24 minus 9, which is going to be 15, and that was because of the subtraction property. Okay? And so lo and behold, I've shown that v equals 15, and notice that this is exactly what I'm asked to prove. And this was exactly what I was given right here. Okay, so that's exactly what I was given, and then exactly what I was asked to prove. And so I can come out here and draw my little square and fill it in, and I'm done with the proof. Okay. Show that k equals 8 if negative 10 equals 10 times the quantity k minus 9. So we're asked to show this. Okay. So what's the given? The given is over here. That's the given right there. That's the given. Okay? So the given is negative 10 equals 10 times the quantity k minus 9. And I'm asked to prove that k equals 8. Okay? So here are my statements. Here are my reasons. Oh, and I forgot to say one thing. Let's jump back here. This is just a small point to make, but it's important. Before you actually start writing the proof, you actually write the word proof, and you put a period and you underline it. And if you're typing it, it's usually bolded and italicized. But you actually write the word proof, period, and underline it. And that's how you know. Again, it's just a convention. So here I would write proof. Here I would write proof, period, underline it, and move on with your life. Okay. So the first statement is exactly what I'm given. Negative 10 equals 10 k minus 9. And I can say that because it was given to me. Okay? It was given to me. So, noticing that I have a 10 and a 10 on both, I have a 10 on both sides, and I can easily divide that out, because remember, that's being multiplied right there. I could divide this by 10, and I could divide that by 10, and the 10s here are going to cancel, right? And I'm really not supposed to be doing any of this math work excuse me, in the proof. I should be doing that on a scratch paper, out to the side like this. So I don't want you to get in the habit of actually writing your scratch work in here. Think about it in your head. Okay? All right, so and the reason for that is that when we get into paragraph proofs, it'll become more clear. All right, so just do your work in your head or do it on another sheet of paper. So if I divided both of these by 10, over here I'm going to have -1, and over here I'm just going to have that quantity in the parentheses left. And what made me have the ability to do that? Well, it was the division property. Okay. And then, of course, I'm going to add 9 to both sides to get rid of that. Blah, blah, blah. And here's the k. And here is -1 plus 9 will indeed give me 8. And that was because of the addition property. Now, you may say, oh, great. K is 8. We're done. That's what we're asked to prove. But not exactly. Why not? Because I have been asked to prove that k equals 8, not 8 equals k. So I actually have one step left here, and it's to flip it around. And what property tells me so that it looks exactly like, notice I want it to look exactly like what I was asked to prove, k equals 8. So why can I flip this around like this? What property tells me that if A equals B, then B equals A? It is, in fact, the symmetric property. Remember that if A equals B, then B equals A. That's the symmetric property. So that's what I'm doing here. I'm just taking the B's and the A's and I'm flipping them. I'm taking the K's and the 8's and I'm flipping them like that. And so now I have exactly what I was asked to prove, k equals 8, k equals 8. So I am done. Okay? All right. Got a nice big one here and we'll be done. So, the given is 4 times the quantity 5n plus 7 minus 3n equals 3, 4n minus 9. Okay? And we're asked to prove that n equals -11. All right? So, here's our proof. We have statements. We have reasons. Okay. So, first we have 4, 5n plus 7 minus 3n equals 3 times 4n minus 9. We can say that because it's what we were given. I notice that I have a couple of distributions to do. Nothing's going to really help me to solve for any of this because I have n's all over the place. I need to start working to get that in. So if I distribute here in this first one, I'm going to have 20n plus 28. I still have the 3n, and I still have equals. If I do this distribution down here, I have 12n minus 27. Even though I did 2 steps right there, they were both the same step. I did distribution and distribution. And so I can say that it was because of the distributive property that I could do that, and I can combine 2 steps into one. And 2 algebraic steps, I mean, not 2 steps of the proof. So now I can combine some of these like terms, but careful of what I need to do here. So this 20n and this -3n technically are combinable because they're both n terms, right? But they're not next to each other. And so what I really have to do, and this is where this is going to start to get really picky for you guys, and I have to be picky. I have to commute the order of those two like this. I have to commute the order of those 2 terms so that I have the n's next to each other now, and that was indeed, like I just said, the commutative property. Okay? Now I can actually combine these, and 20 minus 3 is going to give me 17n, and I still have the plus 28, and I have the 12n and the minus 27. Now, how was I able to do this? How was I able to do 20 minus 3? Right? Well, that was just combining like terms. Combining like terms. Okay. Notice that we normally don't do this commutative step, but we do it in our head because we know that we can commute, and so we actually flip them in our head and then do the arithmetic. Excuse me, but this is what we actually have to do here. And so now I'll just say, since I have to get the n on the left to prove it, I'm going to get the n's over here. So I'll subtract 12n from both sides. And so 17n minus 12n would give me 5n, and I still have the plus 28. 12n minus 12n is going to go away, and I have that. And excuse me. And this is going to give me, and the reason for this was the subtraction property. Okay, and then if I subtract 27 here and here, I get 5n equals negative 55, and that was again from the subtraction property. And then, of course, I divide by 5, and I get n equals negative 11, and that would by the division property. And that's exactly what I needed to find. N equals negative 11. If you need a reminder, it's right here. Notice n equals negative 11 is exactly this business right in here. And so I am done. So I draw my square, and there you go.